Hello, I'm Mike Wheeler, and welcome to Chapter 17's kind of lesson plan, which is GTAW of Plate. This will cover plate and sheet, which is what we're going to be doing in the lab. This will help your welding here, to help your welding on the real world. The ability to put a nice looking bead on a piece of plate or sheet is a must-have for a TIG welder. So focus on your core skills, your base skills. Work really hard in the lab, and you can be one of those gold medal guys on Instagram someday. Although they've got some tricks, some dirty tricks I'll tell you, but we'll talk about that in the lab. So some of the stuff I'm going to talk about today, we talked about in the last lesson. You can't hear enough of it. We're going to talk about torch angle, we're going to talk about tungsten stick out, we're going to talk about gas coverage, all that stuff. So when it comes to torch angle, everything in moderation. We don't want a lot of torch angle. We want, for me, a real kind of sweet spot for me, if I can make my dry erase marker work right. A real sweet spot for me is about 15 degrees. So this angle here, about 15 degrees. Okay, that's where I like to be. I will run straight up and down sometimes, just depending on the application. But for me, 15 degrees is okay. That little bit of push helps my puddle advance. As I'm welding, that arc force kind of pushes the puddle along, helps it run, helps me go a little faster. And the more you TIG weld, what you'll start to realize is that the biggest problem you'll ever have is you're too cold. It took me years to get over this. If you're having problems with TIG welding, one of two things is happening. Either you're too far away from the plate, your arc length is too long, or your amperage is too low. I found myself, as time goes by, I just keep going hotter and hotter and hotter, and just moving faster, and my results keep getting better and better. Now there's a point of diminishing returns in there. I'm not going to weld 16 gauge plate on 200 amps, but I might not run it at 60. I might set my machine at 80 and see what happens. But a lot of times, the hotter I go, the better it runs. So anyway, back towards angle. Everything in moderation. 15 degrees is about the max I ever want. Okay. Gas coverage again. Any more angle than that, and I start pulling contamination from the outside. So like 15 degrees, fine. But if I lean this thing way over like this, it's not going to be fine. I'm going to have problems. And it will also affect my arc length. I've got this drawn really poorly. Arc length, we want this dimension. I like about 3/32 of an inch, which is the same diameter as my tungsten. Really, really close. I like it close enough that that's not a tube. I like it close enough that when I dip my filler in, I've actually got to lift my torch up so that the puddle rising doesn't contaminate my tungsten. Let me draw this bigger. 3/32 of an inch. Okay? That's about what you want. With really small stuff, where you're running a small filler, you can get even closer than that. If you're running aluminum, where you're putting giant dips in, you may need to run an 1/8 inch or more. It all depends. But for us, plate and sheet, 3/32 would be a pretty good starting point. And again, like I said in the last video, if you're not dipping your tungsten every other weld, you're just not trying hard enough. Okay? You're going to dip your tungsten. That's fact of life. The people that have problems learning TIG welding are the people that never sharpen their tungstens. They're so far away. Their arc length is so long, they're never dipping their tungsten. They're also never TIG welding. You just can't learn it that far away. You've got to take some chances. Prep room is not that far away. Tungsten's cheap. I dare you, get in there. Okay? See what you can do. So, tungsten stick out, again, this dimension here should match our inside diameter of our gas cup. Gas cups are given number designations. So it'll be a number 6, number 8, and what these numbers are 1/16 of an inch. So that is 6/16, also known to humans as 3/8. This is 8/16, also known to humans as 1/2 inch. So a number 8, this inside diameter right here is 1/2 inch. What we run is number 7. It's good do it all cup. You can have a little bit of stick out, 7/16 of an inch, which is fine for most stuff, good visibility, but it's small enough you can get into tight spots. And with cups, you're always playing that game. You want as big a cup as you can run for gas coverage, but at some point you just can't get in places. So you got to go down in size. So number 7, just kind of do it all, works really well for us. So filler rod manipulation. Let me erase this stuff. So being able to manipulate the filler rod with good dexterity is going to take you some practice. And what I would advise you do, all of you, is take a piece of filler metal home with you, and whatever you do at home, watching TV, whatever, practice feeding that with both hands. Okay? You can get away for a long time TIG welding without having to learn to feed, without having to learn to feed through your fingers. It's gonna hinder you. You can just feed with your arm in like that, but at some point that's not going to work. You need to work on your skills, practice feeding. And what's really critical is the end of that, where the end of that filler rod hangs out. So I'm going to redraw this, hopefully it'll cleaner this time. So here I've been digging this. So here's my gas cup. This is number 7. So how long can I stick out? That's right, 7/16 of an inch. So here's my arc. Here's my puddle. Now, filler rod. So we've got a fairly good sized shielding envelope here of cover gas. When we're feeding that rod in, we never want to pull the end of it out here. We always want to leave it in here. So I'm going to come in and dip. I'm going to dip like that, and then I'm going to pull it back. I'm never going to pull it back much farther than that, because the end of this is red hot when I pull it out of that puddle. If I pull it out of that shielding atmosphere, it's going to get contaminated instantaneously. And then when I feed it back in and dip, I'm going to put that contamination right in my puddle. So we always want to keep it nice and tight to the arc, really small movements, and that's where that feeding comes in. Is you need to get really fine motor skills to a little bit of dip, so you're not pulling in, going, it'll affect your welding, and it doesn't look cool on Instagram, frankly. So always keep the end of your filler rod in that shielding envelope. It's funny, aluminum is I would say a little less prone to problems than steel is, but aluminum's got its own cleaning thing going on, so that helps. Tungsten contamination. So tungsten contamination can be real minor. You can get these little kind of spots in your tungsten, which is erosion, and it picking up stuff just flying through the air. Or it can be, you've got half piece of filler rod welded to your tungsten. Okay, that's going to happen. It happens to me all the time. So when you get something like this, don't try to grind that off in the grinder. Take a pair of pliers, break it off right at where it starts, and go resharpen that end. A couple reasons for that. One of them is it's just going to take too long trying to grind that off in the grinder. And the other thing too is it'll contaminate the wheels with a huge amount of steel or aluminum or whatever. So don't do that. Break it off, sharpen the end. Don't break half of it off. Break off the 1/4 of an inch. It's got a giant lump on it, and then just go back and sharpen it as usual. How to set welding current. So this works with steel and aluminum to an extent. What I do, I go about 1 amp per every thousandths of material thickness, okay? So what that means is, and it doesn't work for everything. As we get thicker and thicker in plate, it becomes less and less relevant. But for sheet metal, it works pretty well. It's at least a good starting point.